Hey stats class, we're going to go over the idea of a correlation test on this video. So I've got a data set. I'm going to go ahead and put that into my stat editor, just stat enter. Will get me into my editor to clear out these lists and replace them with my new list. Alright, top values are going in list 1, and then the bottom row is going to go into list 2. Alright, notice the first thing it's wanting me to do is a scatter plot, so I'm just going to go to second y equals, make sure my scatter plot is turned on, so enter. If it's not on, I need to highlight on, and I need to highlight the scatter plot. All right, make sure your X and Y list are where your X's and Y's are. If everything's in the right place and it's turned on, you can press zoom 9 on this for zoom stat. All right, or you can also scroll down and find it, and yours again may not be 9, but zoom 9 on this one is the stat plot. Now mine has the regression equation in there. Let me turn that off for just now and go back to the graph. So there's my scatter plot, and now I'm just matching up which one of these looks like that. So it's kind of like, you know, I have some kind of constellation map and I'm looking up at the stars and I'm trying to see which one looks like this, and I can tell that B is the one that matches up here. Alright, the next thing it wants us to do is the linear correlation coefficient. So we've seen how to do it with stat, calculate, and the linreg. If that's all I need was correlation coefficient, then that would be fine. But I'm going to do a regression test. So I'm going to come over here to test, and just, it's at the bottom, so I'm going to press up to get to the bottom. And then I'm going to do a linear regression t-test. So I'm going to hit enter there. My X's are list 1, my Y's are list 2. Make sure your frequency is 1 here. And then, unless it specifies something like, you know, you feel like the correlation is positive, you feel like the correlation will be negative. If it doesn't specify, and it typically doesn't in a correlation test, then you're going to press not equals to. So this is rho, the Greek letter rho. It's like when we use x bar for means and mu for means for the population. So that was sample, that was population. Well, the same thing happens when we're using a value for the measure of how well a line fits data in a sample. We'll use R, but when we are using for a population, we use the Greek letter rho. So rho is like the population version of correlation, and R is the sample, just like sample mean correlation, population mean, population correlation. So we're going to select not equals because it doesn't specify a direction. I've got y1 as where I want to store my regression equation. If that's blank, you just press vars, scroll right to y vars, and then enter a couple of times, and that'll put y1 in there. All right, I'm going to hit calculate. So this is the results of it. If you scroll down at the very bottom here, there's R, so 0.825. And then the next thing it wants to know, and this is why this is at the end after hypothesis test, it wants to know what would the setup for a test be. So there's the Greek letter rho, that's correlation in the population. So the hypothesis is it's always equal to 0, meaning we don't have correlation. Remember, if R equals 0, that means no linear correlation. Well, rho would be no linear correlation in the population. And then when we did our setup, you can see it's up there, rho not equal to 0. That's the test we ran. So check our answer, that's the right setup. It wants to know what is your test statistic. If you scroll back up here, that's the first thing it gives you in the output, 2.92 to 2 decimal places. That's the test statistic, and then the p-value is right below it, just like test statistics were before. So 0. How many places? 3 places, 0.043. All right, and now you compare, just like in the hypothesis test chapter, you compare the p-value to alpha, and we can see our p-value is larger than alpha. So it's greater than alpha, which is the significance level. So there is not sufficient evidence at this level of our significance level to determine that there's correlation. So that's the hypothesis test, comes at the end once we've put in our data, seen a scatter plot, found the correlation value. We run a hypothesis test to determine, okay, that's not 1. You know what I mean by that. This 0.825, that's our correlation coefficient. That's not equal to 1, but is it far enough away from 0? Right? It's not equal to 0. is it far enough away from 0 for us to understand that it's not just chance, it's literally a non-zero value for the population. And the reason something that's so high, like a correlation of 0.825, is so high, and it's we're rejecting the we're failing to reject, I should say, that rho is equal to 0. It's because there's only 6 data points. So when you look at those significance levels of, what does it take to be considered significantly different? With 6, it's very high. It's up in the 8s, high 8s. So it's just because our data set is so small.